before I go forward with that, are there questions? So actually, from here until like probably 2 classes, it's better for you to put on your database hat to the extent you think of databases, because that's much more closer to what we'll be discussing here. Any questions? Yes.
I guess you might be covering this later on this slide, but why do you want to go from completely good structured data to semi-structured data?
No, I don't go from it. It is, so you're talking about why database people might want, okay. So that's basically because there may be lots and lots of, so there are 2 different issues. One is because there may actually be semi-structured data. And secondly, there may be, XML may just be lingua franca, in the sense it's just a language that is shared by multiple different database standards. Okay, so if you have a relational database, somebody else has an object-oriented database, somebody else has an Excel file, somebody else had some sort of a text file, and what is the means by which they transfer, they take queries and transfer results. Okay, to do that essentially is why you want to consider XML.
It's kind of a common interface.
It is. That's the main reason. That's the main reason. By the way, this part actually, the whole, some professors here will kill me for saying this, but XML and directly the many standards regarding XML, they are coming and going. It's a fast-changing world in the sense you make a standard and hope that people will follow it, and if people don't, then you go do something else. Okay. So in fact, even among the years I've been teaching this course, I used to spend more time talking about, so if you're a database guy, the first thing you want to ask yourself is, if I represent the data in some form, how do I query it? That's like a very big thing. For IR folks, it's not a big deal, because the queries and the data are in the same form. Data is text, query is text. Okay, the whole point of databases is you can ask more interesting queries, and to want to give more interesting queries, you need a language. Databases, normal RDBMS has SQL or SQL, structured query language. Okay, so one of the things when you consider data in XML format, then you also want to consider querying over XML data. Okay, so we were talking about keyword search over XML data last class, at the end of last class. Here we will actually be talking about direct querying over XML data. Since the XML data could have been just a translation of relational data, for example. So anything you can do in SQL, you should be able to do with XML data too. Okay, but for that you need a new standard. Something, just like if you understood how to write SQL queries, select, project, join, that's not going to work for XML. So we will talk about a standard called XQuery, which actually which came after many other false starts. There was XML query, XLS, and all these things, and then there was one standard about this thick called XQuery, which essentially allows everything that you can do with SQL plus a lot more. And all that was needed is for people to start using it. And not too many people, as far as I can tell, are using it. And so you don't hear that much about XQuery. I will tell you about the standard a little, but if you are somehow going to use it, you may need to know more about the syntax. Okay, if you are thinking of it from the point of view of databases, you always think in terms of query languages. XQuery is the query language for XML. And as we go forward in today's class, we will talk about semantic web standards, one of which is RDF, Resource Description Framework. And RDF, if all your data is in RDF, then you need a query language for RDF. And that's called Sparkle, SPARQL. Okay, that too sort of looks like, all of these look like SQL in the sense, instead of select, project, join, in XQuery we'll say they have flower expressions, and in Sparkle there is something similar, so you essentially, depending on the representation, you still want to be able to make something like SQL for that data. Okay, that's something that we'll talk about. However, as I said, if not enough people are using this standard, going through the entire manual for that query language is not worth it. Even if I'm teaching databases, I wouldn't have probably taught you all possible use cases of SQL. It's mind-numbingly boring. If you want to do it, you have to do it, but this is like a wasteful way to teach in a classroom. Here I'll go even faster. I'll just show you that this thing exists. Here is how it looks. If you're interested, you go back and read. W3C, World Wide Web Consortium, has all these standards written down. Okay, but as the reason I got into this was with respect to your question as to what I was trying to say is, while the original idea for XML was that everybody will be exchanging data in XML format, and that they could be interesting, that you might actually have front ends. So in fact, let me see, that you could provide an XML front end to the XML front end to the database, so that essentially, as I was saying at the end of last class, even if your database is having relational data, if it puts up an XML front end, that means it should provide output in XML, it should take input in XQuery. And then you need to translate. And research in this area was done, but I don't necessarily know that anybody is actually using it right now as much, which is why I will tell you a little about it. And if you're interested, you can learn more about it. And the answer to your very specific question as to why do I convert very structured information into XML, it's because other unstructured information also can be converted to XML, and that would be the common language. Okay, so that's basically what we are saying. So one thing, as soon as you come to a database view of the world, is you need a schema. Okay, you don't just give a tuple. You need to say that this tuple has the following columns, and these columns have the following semantics, right? Not really semantics per se, but every table, so if I have a table, every tuple has exactly, let's say, 5 fields, and you need to be able to say that. That means, and the first field is this column, second field is this column, third field is this column. Right? That's schema information. That is a schema information. So if normal XML doesn't need to have a schema. If you are converting structured data into XML format, then you may want to provide schema for it, so that then people know that, oh, the first part is actually, so in fact, even as I'm saying this, you must be asking yourself the following question. If I have a table in a database, right, and this one is the student ID, this is the first name, this is the last name, this is the grade, okay, and I might just basically have a tuple like 0175, Rao, and Kampati, and grade, okay. Now, I'll just give this to you as the relation. Okay, and it's very important that I better know that it's coming from this table, and so this first column is student ID, second column is first name, third column is last name, and so on. When I convert this into XML, actually, we already know that you would tag the data already, right? Because this will then become tuple begin or record begin, and then you would say student ID begin 0175, student ID end, and first name begin, Rao, first name end, and so on, right? So the tuple already has the column information. So what else is schema supposed to tell me? At the minimum, the schema is supposed to tell me, for example, is every record supposed to have both a first name and a last name? Must it also have a middle name or not? If it has a grade, if the record has a grade, how many grades are you allowed to have? 1 grade or 5 grades? Do you see what I'm saying? So that's what the schema information is going to tell you. Okay, so for example, I have a paper, let's say, and this is the paper begins, there is a section beginning, and there's some text, and then text ends, and then section ends, then the section begins, the title ends, and so on. Suppose I have an XML file like this. My question is, what is the schema that could have generated an XML file like this? Okay, and for that, essentially, we're asking just as so. If in fact, if I were to give you a tuple which doesn't have the last name information, should you be surprised? Or should you just take it? Okay, if it has no last name, then if it is supposed to have a last name and it doesn't have a last name, you should be worried. And why are you supposed to know that it's supposed to have something? That's what a schema should tell you. That is, every tuple I'm sending you here must have this structure. Okay, so a schema in databases tells you the structure of the tuples, and the same thing in XML too. Okay, the original idea for XML schema was what are called DTDs, document type definitions. In fact, again, XML came from the IR side too. Okay, and so here is like a little description. This is the DTD description for this. It's saying document type paper will contain the paper will contain an element section, and it's clean star. That means it can have 0 or more sections in the paper. Okay, and the section would contain a title and a bunch of other sections. Okay, and then it may also contain text. This is BNF form. This is grammar. And the title would just be character data. And then text is just character data. Right? So if I give you this, then if I were to give an XML paper in XML format, then you can tell whether or not it's a syntactically valid paper. Not if it is semantically valid paper, but whether it is a syntactically valid paper. Right? So, so for example, if it has sections without title, okay, is that okay or not? Well, it is okay because section can just, the paper can have 0 or many sections, and the sections can actually either have title followed by sections or just text. That's what this is telling us. Okay. So if you have this sort of language to write the schema for the structure for the XML file, obviously you can use this also to write the schema for this kind of tables. The tables are way more structured because they will never have clean stars sort of a thing. They'll have one or more first names, one or more last names. That will never happen in a database table. You will have a fixed number of columns. You have a fixed number of columns, right? So if you can do this, for this, you can also do it for normal data. Okay, and so XML file can have a schema. It's an optional thing. If you have a schema, then you can check whether the file is in conformance with the schema. You can then say it's valid XML if you gave the schema. If not, then you just look to see whether tag begin always ended. I mean, if you started a tag, you must end the tag. That's all. Okay. One interesting question, actually, as you're looking at this, is if in fact XML is supposed to be this language where everything can be written. It's a syntactic standard where everything can be written in that standard without too much worry. How come the schema for XML is not in XML? Do you see what I'm saying? Okay. So it just so happened that when in the, I think nowadays actually you still will see, you still hear about document type definitional DTDs, but mostly you actually talk of XML schema, which is DTD in XML format itself. Okay, if you think about this, there should be difficulty in converting this into an XML, right? I mean, you could just start saying doc type is a tag and it ends here. Okay, element is a tag and then it keeps ending here. One more element starts, ends. One more element starts, ends. Okay, if I do this, then DTD will also be in XML format. And if you do that, you'll get what's called the XML schema. That's sort of what everybody uses now. To the extent there are people using schemas for their XML files. Remember that if you are required to give a schema, that's sort of an imposition, right? I mean, if you just tag stuff, then you don't need to give the schema. Okay. Most of the time, what happens is that, for example, if you have something like the Office document, which came, the Microsoft Word document, that came in XML format. Now you can ask yourself, has somebody, since it can actually be opened and people can play around with the tags, right? Is it still valid, syntactically valid? And of course, Word will fail if you actually try to read a corrupted in the sense, corrupted in terms of the tag structure. But if you want to see whether it is valid or not, the schema for that particular XML instance would be stored somewhere. And there is a pointer in the file saying this file corresponds, conforms to the following schema. So if I want to know whether or not this file is written correctly, I'll have to go look at that schema. Okay. So here, for example, is an example of XML schema. In this case, this is the raw data. I don't know whether you can see it, but it says purchase order this is an XML file where it's starting with the tag purchase order, and there is a property order date, which gives the date of the order, and then there is a ship to, and the country name, and the name, the street, the city, the state, the zip, and then ship to ends, then bill to ends, and then there's a comment. There are the items that were actually bought. Okay, this is sort of an XML file corresponding to an entire purchase order. Now the question is, how do I know whether if I make up one more XML file here, it sort of has this structure, am I sure that it has the right syntax or not? So for example, if I have a bill to without the name, is that okay? It will be a valid XML file, right? If I start bill to and I don't have a name field, I only give the address. Is that valid or not? It's a valid XML file, but it's probably not valid in terms of the syntax of a purchase order. To provide the syntax for the purchase order, this is your sort of equivalent of the DTD. This is writing what every purchase order should have, what pieces should have, each of the pieces should have. So for example, if you look into this here, purchase order type is being defined. So this one is a namespace. XML has namespaces. So XML schema definition namespace has complex type, and you're talking about a particular complex type called purchase order, and the purchase order must contain a sequence of things. Okay, first it should have the ship to, then it should have bill to, then it should have comment, then it should have items. And the ship to should be a USA address, bill to should be a USA address, and then you have to somewhere define what a USA address looks like. USA address looks like. You see what I'm saying? So somebody sat down and wrote all this. If you do this, then essentially, given an XML file which is supposed to be a purchase order, I can quickly try to parse it to see whether it is parsable. This is just essentially like saying, schema is like saying the syntax of C language. Compiler, before it actually, compiles the whatever language, C or Pascal or whichever you use, Java, whatever, would basically make sure that what you wrote is syntactically correct. To do that, it needs to see whether it can be parsed according to the rules of the language. In this case, these are the rules of the purchase order language. So for something to be a valid purchase order, it should be parsable like this. Now, suppose a purchase order actually is parsable, does that mean that it is a semantically valid purchase order? Of course not. There may not be such a person. There may not be an address like that. Do you see what I'm saying? I can make up all this other stuff as long as I'm syntactic again. Just as you can write lots and lots of things that look like syntactically valid C and Java programs and spend months debugging it because it doesn't do what it's supposed to do semantically, right? But syntactically wrong, syntactically correct is one step forward at least, and that's what XML schema is doing. Okay, this is, all the XML standards are almost not meant for people to type, especially if you make mistakes in typing, I look at this and shudder because, they're just long sequences. But really, behind it all, it's essentially, the good thing to know is this as well as this is in the same meta syntax. They both have tagged element structure. Okay, except this guy is describing the structure of this guy. And you only need to define it once, and every purchase order file basically will have a pointer to this XML file containing this and saying this is the schema I'm using. Okay, and that's how you can make sure that syntax is correct. Okay, so that's XML schema file. Now, as I said, if you have a schema and you have data from a database point of view, you want to ask queries. Okay, and then there are actually, this is particular. I think this still works. If not, I will send you one more. This is a applet on the web where you can write SQL and XQuery queries on some sample XML database and see whether you know how to write queries if you're into that. Okay, so for example, here is a query. Okay, now the interesting thing is this particular version I'm showing you, again, it's XQuery query, it's still not in XML completely. It almost looks like XML. Anytime I'm talking about a standard for XML, you should be asking yourself, if XML is so important, how come something that does something to XML files is also not in the same standard, right? And it should be possible. So most of what happened is historically is people came up with whatever is a reasonable formalization and then converted it to XML version. So there is an XML version of the XQuery too, which looks even more verbose. Okay. But so in this case, obviously, this one is not exactly in the XML format, but it's saying it says some query, and this query run on some data produces another XML file. Obviously, XML and XQuery should produce data, which should again be in XML format. Okay, because otherwise, then XML is not universal. Okay. So anyway, this is an applet that you can play with, but let me give you a little description, a little background on what XQuery can support. So it's sort of like SQL, but it subsumes SQL. It does everything SQL does. It does everything IR people are interested in doing. It does even more. It actually also changes the format of the data. Okay, so in an XQuery query, you can give an XQuery query to do anything that you can do in SQL. You can give an XQuery query to do any keyword search that you can do in IR. You can also give an XQuery query to rewrite the data into a different format. So in some sense, in that case, XQuery is playing the role of style sheets. Because style sheets, I remember I said that last class, style sheets takes an XML, converts into HTML. That's a translation. Okay? And so you can actually write even that translation in XQuery. So you can take a particular data in with its own tags and change the tags when you output it. So for example, if you have a book with author field, you don't like author, you want to call it writer, then you can output it with the author field changed to writer field. The tag changed to writer. So that's also allowed in XQuery. Okay. There are, I think, they basically, the thing about XQuery language is it was designed by a standards committee, and they were thinking of what anybody in the world could possibly want to do with XML formatted data. They could be IR folks, they could be folks who are interested in sequence data, in which case you would ask certain questions that would make sense, like, start from the 14th element of the data, go all the way to 84th element. I would be able to say that easily in XQuery. I'll be able to say everything in SQL in XQuery. I'll be able to say everything about keyword search. So, IR folks are easy to make happy because they were only asking keywords. That can be supported. And as I said, you can also support translation. Okay, just as SQL has select project, select from where, right? Here, XQuery has, flower expressions for, binds variables to nodes and then let computes, variables to aggregates. We'll show you in examples. Where shows the parts of the XML formula that you're supposed to be looking at, and return constructs the output item. This is a big difference from SQL. Return just returns some columns. Here you can construct an entire XML file, entirely new XML file. Okay. So suppose I have this DTD or equivalent in XML schema, where essentially these are books. Okay, a bibliography of books. A book has a title and some number of authors, some number of editors, and a publisher and a price. In this case, actually, it's saying either authors or editors, or both are relevant. Okay, and then book has a year. Author has a last and first name, editor has last, first, and affiliation, title is character data, last name is character data, first name is character data, and so on. Easy to read, this is not particularly hard to read. Okay. So if this is the data that you have, a bunch of books from Amazon, let's say, have this kind of, all the books are output this way, are stored this way, then I can ask the following query. And this query essentially is saying, for all books that were published after 1991, please return the book record with the year changed from a tag to an attribute. Okay? So in my normal case, basically the year was presumably, I don't know, it's not right here. 1, 2, 3, book year, yeah. So year is actually it's already an attribute in this case. But actually, let's see what. Suppose it was not an attribute, then and if it was a tag begin, year begin, the year number, year end, I want to change it to an attribute. Okay, so this is what this query is saying. You start from the beginning. Bibliography is the beginning of the file, and for each element in the bib/book, where the publisher of this element is Edison Wesley, and the year of the book is greater than 1991, return the following record. Say book, year equal to whatever the year you picked up, and the title of the book, and then you just enter the book. And if I were to run it on my data, I will get output like this. Okay? Again, these are query languages. If you feel like asking a query, you should try some queries yourself. But there is not too much I can do in terms of giving you every possible piece of the syntax. Especially because before this class ends, I will talk about yet another query language called Sparkle, which has its own separate syntax. Okay. Here is another example query, which is kind of more interesting. So this says return the books that cost more at Amazon than at FatBrain. FatBrain used to be a bookstore. I don't know whether it's actually available anymore. And suppose both these guys supposedly are giving big XML files containing all their books to you. Okay? And furthermore, they also use the same DTD, which doesn't really happen in real world, but suppose they use that. That means they use the same tags and same syntax. Okay? Then basically I am picking, so this is the Amazon, which is, one good thing about XML XQuery, of course, is that all these XML documents are on the web, so you can refer to them by their URLs. Okay, so here the Amazon, let Amazon be, this is the first time you're using this let Amazon be the document which is at Amazon books.xml, and FatBrain be the document that is stored in fatbrain.com, books.xml. And for a book from Amazon's books, that means, go to Amazon's XML list, go to the books part, and then get a book, iterate with it. And similarly, get the book also from the FatBrains, where the two books have the same ISBN number, that means they have the same index, they're the same book, okay? And then the price at Amazon is greater than the price at FatBrain, then return the book in this format. Now notice that when I'm doing this, I'm in essence kind of doing joins over two tables. This is more like an SQL sort of query. Okay, so suffice it to say that I think the next slide actually says it. Comparison to SQL, if you compare XQuery to SQL, there's a huge number of use cases. I just showed you 2. Okay, but basically you can assume that XQuery supports every type of SQL query. Okay, it also has support for construction. That means it can construct arbitrary results, using XML format. Okay, it also allows path expressions. So you can say element ... element. That means start from book and skip fields until you reach the internal element of a book called price, for example. So it could be nested. Book has the purchase information which has price, for example. So you can use the path expression to get there. Okay. It also allows simple text queries. It also allows queries on tag elements. That's the other thing that normally in a relational database you can't say, give me all the tuples which do not have which do not have any value stored in the last name. That's like a null value, right? I can say it here. I can also, for example, say, give me all the books which have more than 7 authors. That's not about the content of the book. It is about the syntax of the book, essentially. I want to read books which are written by more than 7 authors. So that's something that's pretty hard to talk about here, because in essence, the way you have to do it in a normal relational database table is you have to put all the authors in one column, essentially. And then you need to kind of do a constraint on that. Whereas here, you can also basically query the tags directly. The tags are part of your XQuery. Okay, so the difference between data and metadata disappears. Okay, that's why you can change the output to have different tags than the input. And if you ever forget that, remember XSL, because XSL takes input in some format and makes sure that the output has the HTML tag format. Otherwise, it can't be displayed. Yes?
You don't need to put all the authors in the SQL column. Probably will have a different relation than perhaps these 2 authors.
So how many authors are going to be there?
That's what the other relation would, like for each entry would have an entry in that relation for the maps.
So
Yeah,
no, but the point is, you need to know how many authors are going to be there, right?
Just make it point key, but it's not unique in the table. So you can say, well, author ID,
Oh, okay.
whatever.
Okay, so I understand what you. So you're saying the book basically, the authors of the book are in terms of key tags.
Okay. You will be duplicating the data without.
That's part of it, and partly also, if you view the author information as part of book, then in essence, a book with 1 author is a different tuple than a book with 2 authors, and a book with 3 authors. And in essence, by doing what you did, you are taking a union of all these schemas. So you have a disjunctive schema. Okay? Whereas XML doesn't care. XML basically supports no schema to begin with. So when you're going from no schema to conjunctive schema, you go through disjunctive schema. Okay? Think of XML as allowing you to say just the structure you have. Whereas databases will require you to, basically give you the structure, upfront. Okay? Anyway, so these are some of the differences, some of the comparisons to SQL. From XQuery. Okay. You're welcome to look at the XQuery standard more and play with it if you're interested in writing queries for that. Okay. As I said, I'm not completely sure who's actually using it anymore. It's interesting from an academic point of view. Okay. And then this is the point I was making last time, and I was also saying earlier in the class, which is if you have an SQL database, it can put an XML front end. And all that means is it should be able to accept XQuery, and it should be able to convert an XQuery into a set of SQL queries. I said set because it's not clear that every XQuery has a unique SQL translation. Okay. In fact, there are situations, since XQuery, for example, allows you queries on the metadata, which is the tag information, that makes it harder to convert into SQL sometimes. Okay, so it's a non-trivial conversion to go from an XQuery to equivalent set of SQL queries. And then the SQL queries run on the relational data, and you get relations, and you quickly tag them with the column names and output. Okay, if you do this, then it doesn't really matter that you are using relational databases. And similarly, if somebody else is using an object-oriented database, that too can be supported. Right? In the sense that that too would take, it would probably convert the query into its own native query language. And so all they have to provide is this front end. And that was part of the reason, for a while at least, database people were quite interested in XML. It hasn't particularly come to pass, as far as I can tell. Okay, but it's an interesting dream that people can all put XML front ends. It's kind of interesting, actually. This is sort of a big digression, but to some extent, the advance of technology has reduced standardization. Okay, how many of you know Esperanto, the word Esperanto? So the only guy who seems to know is that guy who also knew the psychologist's name. None of you know Esperanto? Okay, Esperanto, what was the deal with Esperanto?
Artificial universal language.
Artificial universal language that was created at one point of time. Why? Because people felt the only way people can understand each other is, they all speak the same language. So we'll standardize Esperanto. It has this beautiful structure as certified by the guy who invented it, and nobody else liked it. And then there was French people who were saying, actually English then became sort of lingua franca for a while, which itself is sort of ironic because lingua franca is a French word and English became lingua franca. But now you almost don't need a lingua franca. Everybody can speak their own languages. I mean, of course, the guys from those of you who have read Hitchhiker's Guide to the Galaxy know Babelfish. But even if you don't have Babelfish, we are getting Babelfish right now through all these machine translators. So in some sense, the advance of technology has made us all be unique. I can be talking in my own crazy language, and you can all have your Babelfish in your, and that's what is happening currently in UN, right? Have you seen people giving these boring speeches in UN General Assembly, and there's always like 10 to 15 minute difference before people actually laugh? That's because somebody is translating what he's saying into this other language, and then they get this and they laugh. Okay, but that's fine. You avoid standardization, and you essentially provide, pairwise translators. You see, okay? So that's sort of what, XML is sort of Esperanto, and so in some sense, it has reached, there's nothing wrong particularly with Esperanto, it's just that people didn't use it, okay? And for a while people used English, and now they don't have to use English. Okay, I mean, everybody can use their own language, and the technology will allow us to just be, completely customized to ourselves and not anybody else. Okay, and so that's sort of what's happening here too, I think, to some extent. Okay, so that's at least the reason why, originally there was a lot of interest, providing this front end. And if you are doing this front end, there are interesting papers about 5 to 8 years back on converting XQuery into SQL. Okay, and there are some non-trivial problems there. As I said, one single XQuery might correspond to a union of SQL. Sometimes it's not even a finite union. Okay, and this stuff, as relations are being spewed out, tagging them, to me, I think this is just obvious. But people have written papers on eager versus lazy tagging. These are database people, they're interested in efficiency, and they wrote a paper on how to fast tag relational data that's coming out so that you can send out XML data. This is work that's been done on those. Okay, so that's about XML. Are there any questions? So what I did till now is XML, the standard, and why you are interested in it. Coming from IR, you want to provide more structure. Coming from databases, you want to allow less structure. And both are very, noble objectives for those communities. Okay, and then talked about how to use XML from the IR side in terms of the keyword search on XML files. Okay, and then I also talked about how to use XML from the database side, which is today the schema language, the query language, and what those standards. They're out there, at least you know that they're there. Okay, so I'm going to kind of move out of XML right now a little bit. But before that, are there any questions? Yeah.
How foreign keys are expressed in XML schema?
Talk to me afterwards. Okay. Other questions? Okay. A simple idea is that there are OIDs, object IDs are allowed in XML. As to how exactly they're written in the XML schema, I don't quite know. Okay. So now I will start talking a little bit about XML provides structure to the data, and it has tags, and those tags might mean something to you, and you tend to think that XML has meaning. But it's very important to understand that XML is syntax, does not have meaning. And there's a sentence there, does anybody guess, does anybody have any context? Yes?
It's a grammatically correct sentence that simply doesn't mean anything.
Exactly. So, colorless green ideas sleeping furiously. This is a sentence that Noam Chomsky gave to point out that that we all are born with a universal grammar, embedded in our brains, and we sort of it's sort of a disjunction of grammars corresponding to possible natural languages. And based on where you actually wind up hearing the language, you start, tuning it to the grammar of that region. Okay? And kids understand syntax way before they understand semantics. Okay? And so, in fact, this is the point. If you tell a kid, a grammatically incorrect sentence, a syntactically incorrect sentence, saying colorless, furiously, green sleep ideas, the kid will look at you and think, I wish there are better adults than you in my life, that I can learn language better. Whereas even kids who just started learning language tend to essentially, realize that this is a well-spoken sentence. It has no meaning whatsoever, but it's a well-spoken sentence. It's grammatically correct. This is like having a purchase order which has ship to information and bill to information. All the syntactic elements are correct, but that doesn't necessarily mean that it's a valid purchase order. It's valid syntactically, but it may be that there is no person actually living there at that address, and there is no person that you can bill to. Okay, semantics are a completely different issue. Okay, so that's basically what I want to push a little bit, and then talk about how do we try to also provide semantics for the data, which is what semantic web standards are all about. Okay, but we'll get through that in a couple of slides. So if you have some, so basically think of textual data that's there. So if you have, all of this is to try and say that just because you have an XML file, it doesn't mean an XML file has machine accessible meaning. Okay, we tend to read the tags. Those tags mean something in English to us, and so we think it should mean the same thing to the machine. There's no real reason for that to happen. And if it's obvious to you, these slides are not, they're just a slight digression. If not, I make that point quite tellingly. So if you have a bunch of text, right, this is what a web page in natural language might look like to a machine. So unless it knows how to do natural language processing, it doesn't have any structure to this. Okay? And I know that there are at least 2 or 3 people who can read this. I have no clue what I showed you. So if I'm calling you names, the 2 of you, I didn't mean to. You guys just have something in Chinese, I guess. There. Okay. And then XML allows meaningful tags. So suppose I have this, and you say, I have no idea what the heck is going on. And then I put these tags. The rest of you, other than the 2 guys who already read the previous thing, and probably I don't even know whether it actually has this structure or not, but now you think, I know what this is really about, right? Because this is the name, this is the education, this is the work, this whole thing is a capital meter, the CV, and this is some private information about the person. So you feel you understood something. And so you tend to think your machine also understands the same thing. But you understand this because the work has a meaning to you. But the machine just realizes that work is a tag. Okay? So really to put yourself in the machine's place, look at it this way. I have no Greek students in the class, and are very good mathematically oriented students. So suppose I have now said these are the tags. If I went from the first slide to this, all you would have said is, yeah, this file has some sort of a structure. I have no clue what that structure is. Right? This previous slide sort of gave you this false sense of security, saying, I know this is name, so I can bring in all I know about names. And this is education, I can bring in all I know about education. Okay? But your machine sort of looks at it this way, because it's, stuff here, and some stuff has been, you put some angle brackets around some stuff and said it is other kind of stuff there. Okay? So, if you don't feel that you particularly understood more about this, other than that it has pieces, then you know what a machine gets from XML. Okay? If you have XML schema, all it will say is everything will have one of these, and one of these, and one of these. I don't know what those are, but it will have one of those, that's all. Okay? Now, go forward. Schemas do help. As I said, essentially, if I have schema information, which sort of, and so that these two XML files are valid with respect to the schema information, then schema will at least tell me to see whether or not everybody has the required number of fields. Right, that's all. I don't know what those fields are. I just see if they have required number of fields. Okay? So, for example, this one has, there's an XML, it's whatever, chi, psi, there's a chi psi here, and so on. So at least you think that you can do aggregate queries. Get me all the chi psis from all the files you're looking at. So I can take this, and put a big list of them and give it to you. Right? That's what schemas will help you do. You are able to do this without knowing anything about what chi psi is. It's just that that's where it lives. Okay? But the problem is not everybody is going to use the same schema. So somebody else might have these tags, right? They use leadbats, I guess. And so they have their tags. Those are tags too. Now, you may be thinking maybe this is the same as this, but you don't know. I mean, if you did that, you're making an inductive leap. You're just making a jump. Okay? If you really want to be sure that this part is the same as this part, somebody should give you that information. Okay? So you need a way of mapping schemas from one schema to another schema. So you need to say, if ever you have a tag of this form, it is also like having a tag of this form. This, basically, if you have a book which has a writer field, another book which has an author field, okay, then I ask you, get me all the book authors, you would not get the writer. But maybe you should get the writer, if in fact writer is the same as the author. But how are you supposed to know? You may know because you have meanings for the words writer and author, but your machine doesn't. And you may know it for books. If I actually make up XML data for some crazy biology experiment, then you don't know. I make up these tags. The tags are just as meaningless as the rest of the data for you. And you don't know whether two different tags, which are syntactically different, are actually same or different. Okay? So those are all the steps that are missing despite the fact that you put in the syntactic structure. Okay? And so what we want to do from here on is to actually provide those missing links. So provide connections. So the first question is, how does one give meaning? Why did you know this education? Why did you know this work? How did you get the meaning? Okay, this is of course, to some extent completely outside of this course. It's a much more general issue. The position that is taken in general is that meaning comes from interrelations. As this guy Shakespeare said, a rose by any other name will still be, whatever it does. I forgot the rest of the word. Okay. So the point is, it's not the name that matters. And kids know this. Even little kids know this. They do pretend games. Right? And they'll change their name for a while. And then they will still be able to have meaningful conversation with respect to that new syntax, new meaning. Okay? So the point is, the reason you know about work is because you have some background knowledge about work as to how work connects to everything else you know in your world. Okay? That's what is missing here. For the machine, there is no background knowledge. So if there is a place where the work actually winds up becoming part of its background knowledge, then the machine can do what you are doing. Okay? And that's what semantic web standards try to do to some extent. Okay? That's what they try to do. Okay? Now, one thing before I go forward is you can also provide meaning by just hard coding. So if you happen to know that your entire life you're going to look at XML data of this form, okay, and you happen to know that most people will be asking for this stuff, you can write a program which essentially hard codes the meaning for these tags. Okay. The bigger question is, then you will have to do it for each separate XML schema. There is a particular file. That's what currently happens. So the purchase order, can be understood by XML file of purchase orders, can be understood by programs which process purchase orders, whose only goal in life is to process purchase orders. And they will only understand those words, and those words have actually been hard-coded in terms of their meaning. If you change any of the words to a synonym, they're dead, unless that too is hard-coded. So the question is whether you can do a more open-ended way of making tags interoperate between files, between XML files. And that's what semantic web standards are all. Okay? So, this is the summary of XML and meaning. XML is a purely syntactic standard. Saying that something is in XML format is like saying that something is in list format or a table format. Just because something is in a table format, do you know more about it? No, you know that it's in a table format, that's all. Okay? It's not like saying that something is in English or C++, etc. because English has meaning to most of you, I hope. The rest of you who are here are not getting whatever I'm saying. And C++ has meaning to the computer. Say they have implied semantics, okay? But saying something is a table doesn't have any semantics whatsoever. Tags in XML do not upfront have any meaning, unless they have been standardized. You and I agree that whenever I say this tag, this is what we are supposed to mean by that. So, but then we understand the meaning. The machine doesn't. Okay, for the machine to understand, you need to write a specific program just for that XML file. Okay. So such agreements and standardization are possible for specific subtasks. For example, HTML has semantics because all browsers understand HTML. They know all browsers do the same thing when you say bold. All browsers do the same thing when you say H3, which is the header, so on. Okay. Tags meaning can be expressed, however, by relating them to other tags. That's what we do when we are trying to understand meanings of things. So the question then is, how do I provide a language where I can relate tags to other tags? And this is the usual knowledge representation. This is the quest of knowledge representation, writing background knowledge that you have about a domain in some formal language. Okay? If you take something like Intro to AI or any of the AI courses or any other related courses, you would, for example, know logical representations for knowledge or probabilistic representations for knowledge, all of which have well-known semantics. If you write your knowledge in those representations, then your background knowledge in those representations, then you can use logical inferencing or probabilistic inferencing to answer some of these things. Now, of course, this makes life much harder because if you write whatever you know in first order logic, and then I ask you a question on the database. It's not a database, it's a knowledge base. Then how long does it take, that procedure take, to tell you whether or not what the answer is? So normally in databases, you give a query, you get an answer. And there's this question of worst case complexity. Okay? Worst case complexity for relational databases is still for now. Okay? If I write first order logic, background knowledge, first order logic, and then so then if I ask a query to a first order logic knowledge base, then it turns out that it's only semi-decidable to answer queries. That means if the question, if I ask you the following thing: is it true, given your database, is this theorem true? If the theorem actually happens to be true, you will find it before universe ends. You will find the proof before universe ends. If the theorem does not happen to be true, you will never find it. That means it's not a terminating computation. Now imagine, giving to a layperson, typing away at the Google keyword box that, yeah, give me whatever you want, I'll come back, either before or after the universe ends. That's my good, it's only semi-decidable. So as we go with the extra background knowledge, the inferencing becomes harder. Okay? But you're able to infer more things the way people infer because of the availability of background knowledge. Okay? So this is basically the territory that we're going into. We went from IR, from normal text XML, and then XML kind of provides at least the structure, and then we are saying even that's not enough, we now want to provide background knowledge. Okay? And if you want to write background knowledge, those of you who have done any logic courses, you would say, yeah, we'll write it in logic and we'll be done. And you are right. All semantic web is a particular syntax for writing logical sentences. RDF turns out to be a syntax for writing binary predicates. That means a predicate with 2 arguments. That's what RDF is. Okay? Anyway, so to give you the background of the schema, the languages in semantic web, there are 2 things that you need to understand. One is RDF, that most of you probably heard of, at least some of you probably heard of. How many of you have heard of RDF? Okay, not too many. But anyway, you will know now. How many of you have heard of logic? The rest of you are illogical, I guess. But anyway, so we will, I guess, what I'm doing here, I guess you will get something at a certain level, but if you happen to know AI and logic, you might get a lot more. That's okay. Okay, so what I'm going to do is go through a story. Several of you here know the story, and some of you don't. I probably should have gone with a Bible story so that majority won't know it. I went with a story from Hindu mythology, so majority knows it, and so part of the point is lost. But let's say, so here is this happens to be an epic in Hindu mythology, and this one has the following text: Rama was the son of King Dasharatha. He had 3 brothers. He married Sita. Ramayana tells the story of Rama's quest to rescue Sita when she is abducted by Ravana. This is short description. Those guys actually write a really big book to describe this story. Okay, so that's a short description I have there. So if I have my data in this form about this story, what kind of queries can I ask? I can ask a query like Rama, Sita. Okay, and so then my search engine will find me this entire stuff and show it to me. Here are places where Rama and Sita are occurring, in the file. Those are the kind of queries you can ask. Okay. But when you heard me say this in English, you can ask a lot more queries than that kind of queries. Right? In particular, I might, you almost can't read this, but the query here says, married Rama X. So who did Rama marry? That's question answering. Right? And obviously all of you can answer this. Even though you you haven't read Ramayana, some of you haven't read Ramayana. You still can answer this just because you understood this story. You convert it into some sort of background representation, okay? And then, so you can answer this query. And the reason, in a way, you can say you can answer this query is because, in some sense, you summarize the knowledge in this story in a form, let's say, like this. This is a logical form, okay? It's saying there is a binary relation called married, which holds between Rama and Sita, and there is a relation called son of, which holds between Dasharatha and Rama. There is a relation called abduct that holds between Ravana and Sita, and there is a relation called rescues that holds between Rama and Sita. Okay, in fact, you can even say rescues can be a three-ary relation. Rama rescues Sita from Ravana, in which case it became a triple. Okay, three-ary predicate, but let's assume in this case I just have a two-ary predicate. Now, had I been able to look at this story and write this stuff, or if I just gave you this stuff upfront without getting you through English, you could have answered queries like this. Of course, you can still answer query like this. That's no big deal. But you can now answer queries also like that. Okay? The whole point of RDF standard in semantic web is to essentially, it provides the standards for writing triples like this. In this particular case, they are all binary relations. They're relations between two entities at a time. Okay? And RDF always only allows relations between two entities at a time. Okay? Now, first question, even before I go forward, is that a huge limitation or not? In fact, I said that really what I should have probably done is to say rescues, the real version of rescues to be rescues Rama, Sita, Ravana. Right? Then I can't write it in RDF because it's a ternary predicate. In general, you can have n-ary predicates. However, I can, if I have knowledge like this, okay, I can write this in terms of there is a rescue going on. Who is rescuing? Rescuer, Rama. This is rescue number 007. Okay? And in this rescue, the rescuer is Rama. And the rescuee is Sita. And the bad guy, I mean, I guess there should be better idea than that. Bad guy is Ravana. Rescued from. So I can write, so I can now each of these, so this thing can be written as rescue 007 is a type of rescue, and then this is an RDF triple. In rescue 007, the rescuer is Rama. In rescue 007, the rescuee is Sita. In rescue 007, the bad guy is Rama. So even though it looks as if RDF is sort of a limiting representation because it only allows binary relations, you can convert n-ary relations to binary relations. Okay, you can't convert n-ary relations to unary relations. That would be a huge blow-up. But in general, you can easily convert n-ary relations to binary relations. Okay, and that's why RDF is used sort of as a standard for writing base facts. Okay, now the point is, this is logical syntax. This is how people write logical syntax. Now, in fact, the question is, what is RDF doing? It just provides an XML syntax for this. The point of RDF is, you would say Rama, it's a URI, Universal Resource Descriptor. So it's like a URL for Rama. There's a URL for Sita. There's a URL also for the rescues relation. And all you are saying is there is an RDF triple saying the rescues relation holds between the Rama entity and the Sita entity. And for that you need some syntax. Right? We'll show you some syntax in a minute. But that's what RDF is all about. Yes?
Are the relations transfer?
What do you mean are the relations transfer? Whatever I said is what I said. This is what I said.
Let's say I have a relation.
Wait. Okay, so this is what I said. Okay, my last question. Okay, so actually, so I started with these as the kind of queries I can answer if I have the language knowledge in this form. I can answer these kinds of queries if I have knowledge in this form. And I said, if in fact, instead of telling you the story in English, had I told you the story in RDF, that would have made for a boring storytelling for humans, but it's a beautiful storytelling for machines, because they can now answer more interesting logical queries. And while semantic web expects that you give this, in an RDF standard, the expectation is that you write everything in RDF yourself. The next topic we will talk about called information extraction. What it tries to do is it starts from text here and